What's our delay today? We have okay, guys, we got a 30-second delay. That's fine. Revish, yes, this session will be useful for you. While you might not get assessed on Surds in level 2, it is something very useful to kind of remember, and it is a bit of revision from yesterday, and it just kind of adds up a little bit more. So I would say, yeah, it's pretty handy to have in your arsenal, even if you're just level 2 and kind of joining in. So guys, first off, I just want to apologize for on Tuesday, because yeah, I had some issues with internet, with my wife being an essential worker, and she kind of needed to use yeah, she was using pretty much the whole bandwidth, and I do apologize about that. But in saying that, I'll tell you what, we're going to get started straight away. So we are actually doing intro to complex numbers. So that's what we're going to be doing today. But the topic predominantly that we're going to be looking at today is surds. And if you forgot what that is basically dealing with a square root symbol. All right. And so I know that in the level 2 session yesterday, we covered quite a bit of the square root symbol. And yeah, so if you are level 2 and kind of joining us right now, yeah, I think you guys should be okay with this particular part anyway. And in fact, I think you'll be okay for this entire session, because the work we're going to be doing with is just numbers. So we'll kind of get started. And as I said to you guys, I'm going to be looking at surds. So I guess the best way to kind of start looking at surds is because it is necessary for complex numbers, and understanding how kind of complex numbers, when you start working around with complex numbers, how you do in surds actually helps out with the complex numbers itself. So to kind of get you guys started, what we're going to be doing is revisiting some of your perfect square numbers. All right. What I mean by perfect square numbers is these numbers here. For example, 1 squared, 2 squared, 3 squared, and then you got 4 squared, 5 squared, and it just literally keeps going, right? We've got 64, 81, 100. All of these numbers are like x squared, for example. So I'm just saying they're like 1 squared, 2 squared, and so on. Now these numbers are very, very important when you're dealing with simplifying surds. What I mean by that is, for example, you could have a question like this, where they say simplify, and I put an example 1 here. Simplify something like square root of 98. All right. And what they want you to do is they don't want you to write the answer as a decimal point. All right. So I know that most people are thinking, right now I could just go, all right, I could just open up my calculator and go and type in square root of 98. And there you go. There's my answer. Is this equals x over b squared? I'm not sure what that you're talking about, friction, but I'll go through this and we'll come back to that. All right, so I'm just doing simplification at the moment, man. So as you can see, you're getting 9.8999 as a decimal, right? And so you don't really want to have that answer because you're going to be rounding it up. But what you want to do is you want to simplify this. And so I guess that's where you kind of have to go into this little yellow box and have a look at these numbers and see if the 98 has one of these numbers as a factor. And I guess this kind of helps you guys with not actually using the calculator, because in 98 you can see that it's 49 multiplied by 2. All right, and remember yesterday how we did this. I think with the level 2s I did this yesterday, but pretty much the same idea that happens here. All right, because what you have here is, I'm going to tell you guys what it looks like. It actually looks like this: square root of 49 multiplied by square root of 2. Square root of 49 is 7, and then square root of 2, we can't really do anything, so we just leave it as this. And this becomes your answer that's actually simplified. So if you look at it, 7 times square root of 2, as you can see, it's the same answers here. But here's the thing. So if you are level 2 and you're kind of joining us right now and going, how did that happen? Well, if you think about it, what we have is we have 2 elements inside, right? We've got 49 and we've got 2. And if you remember, they both have powers of 1, and the square root symbol actually has a 2 in front of that square root symbol. So then this could be written as 49 to the power of half multiplied by 2 to the power of half. And if you remember, anything to the power of half is the same thing as saying square root. So this will become square root of 49 times square root of 2, and that's how we end up with the same answer. So as you can see, the work that you guys did in level 2, it does come in handy with this when you actually start doing these kinds of things. All right, particularly with the index, the powers, and working with surds and so on. So what we're going to do is, are we okay with that? And if we're okay with that, I'd like to give you guys a couple of quick questions so we can kind of just, have a look at it and just kind of move on after that. So I'll keep an eye on the chat, but if you are ready to get going, so here's your first question. I'll give you guys some simple ones, so I don't want to complicate it too much for you guys. All right, so we'll just do something like this. Square root of 50. Lucas, it depends, man. It depends which one you kind of not prepared for, because yeah, I don't think you can actually say that any one of those 3 papers are difficult. It's just every year they change it up. I think last year I found complex numbers super easy compared to previous years. So it's just different each year. So you can't really tell, mate. So 2 quick questions for you guys there. And as always, I'm going to give you guys about 30 seconds. Just quickly get it out of the way. And then we'll move on to some expressions as well. So these are just looking at numbers, and then we'll start looking at expressions very soon. Okay, so I'll do the first one here. So 50, looking at 50, I can see that it's actually 25 times 2. So I'm going to do that straight away. Square root of 25 times 2, and then split it up as square root of 25, square root of 2. Square root of 25 is 5. So end up with 5 square root 2. And looking at the next one, we've got square root of 12. So I'm going to be using 4 in this case. So that ends up being square root of 4 times 3. And then I've got square root of 4 multiplied by square root of 3. Square root of 4 is 2. And so my answer ends up being 2 root 3. Okay, so that was kind of like starting off real simple. And now just we're going to have a look at a couple of algebraic expressions. All right. We'll have a look at a couple of algebraic expressions so that you guys can actually see what happens when letters are involved. So I'm going to leave that as it is. And as always, I'm going to do an example on the side here so you guys have something to look at. So what happens when you do algebraic expressions? So with algebraic expressions, let's say we've got something like this. 25 x to the power of 6 and y to the power of 8. Okay, so if we have this, and I know the level 2s that are here, you guys should be able to just kind of nail this, because this is pretty much what we did yesterday. But after a while you do it so often that you kind of know what starts to happen here. All right, What I mean by that is, I mean, you can still do it how we did it yesterday. So we could put a little 1 next to 25 and a 2 outside. So what you're going to end up with is 25 to the power of half, x to the power of 6 over 2, y to the power of 8 over 2. All right, and 25 to the power of half is 5, 6 over 2 is 3, and then 8 over 2 is 4. Now what you could do is you could actually directly go from here to here. All right, and the way you do that is by looking at the power, especially if it's squared, you can just divide the powers by 2 because you know that's what's going to happen. And if it's cube root, then you divide by 3 and so on. So I'll give you guys, as always, a couple of questions for you guys to try and do. So we are going to do square root of Okay, I've checked up 2 questions there for you guys. So question D, I actually want you guys to leave it in a surd form. All right, when they say a surd form, that means you actually want to have what do you call it? A square root symbol in it. Salty, if you're here, that means you're on the live stream. But I can, it's weird. So guys, as always, I'm going to give you guys a couple of, I think this one I'm going to give you guys about a minute because I think the C you should be okay with. D is a little bit tricky, but I will get you guys to have a go with D. Yeah, I know you guys will be fine with C, but D, you got to make sure you have square root symbol left over in the end. Yep, no, friction, that's fine. It's meant to be confusing for you guys, but just, as I said, like yesterday when I was talking to you guys, is that, just have a crack, even if you're wrong, that's absolutely fine. Just have a go at it. I am going to give you guys another question very similar to D because I realized I kind of threw you guys in the deep end, but that's all right. X squared 5 square root of x to the power of 7 over 2 x 5 over 2. Yeah, now Ravish, you are correct, and Uncheckle, I know what you're trying to think as well. You guys are correct, but you got to write this in a square root symbol, and I'll show you guys now. All right, so let's just do C quickly, and then I'll show you guys how D actually works out. C, I think you guys know what's happening because square root of 16. This basically becomes square root of 16, square root of x to the power of 8, square root of y to the power of 4. Those are some horrible numbers there, but let's... Square root of 16 is 4, square root of x to the power of 8 is x to the power of 4, and square root of y to the power of 4 is y squared. Okay, so let's have a look at D. All right, I'm going to give you guys a bit more room. I need a bit more room for D. Like I said, what you guys did, there's nothing wrong with what you guys did. So I think so far I'm looking at some of the answers. I've got 5 x over x to the power of 7 over 2, 5y to the power of 5 over 2. Okay, so the way we're going to do this is first we're going to have to split all of these things up. All right, what I mean by splitting is when you actually have an odd number as a power, and when you divide it by 2, you're going to end up with a decimal point, right? So when you have odd numbers, what you need to do is go back to almost like what you did in level 1, and you need to kind of like split it up. So I think that's what I'm looking for, Snapping Turtle, but let's have a look. So the first thing I'm going to do is I'm going to get rid of the 50, and I'm going to write it as 25 times 2. Now, the x to the power of 7, what I'm going to do is I'm going to write it as x to the power of 6 times x to the power of 1. Because remember, the 6 and 1 makes a 7. And y to the power of 5, I'm going to split it up as y to the power of 4 times y to the power of 1. So you guys can see that this is how the 4 and 1 actually ends up being. So at this point, what I'm going to do is I'm going to look at everything that I can actually square root. And if I look at it, 25, I can do square root of. X to the power of 6, I can do square root of. Y to the power of 4, I can do square root of. Which means I take square root of 25 times square root of x to the power of 6 times square root of y to the power of 4 times whatever is left over, which happens to be 2xy. So that's that, and that, which ends up being here. Actually, let me try and do that better. Okay, so now I could actually start square rooting everything. So square root of 25 is 5. Square root of x to the power of 6 is x cubed. Square root of y to the power of 4 is y squared. And then multiplied by 2xy. Because I can't really do anything with the 2xy. So putting it all together, I'm going to get 5x cubed y squared square root of 2xy. So if that's all right, just let me know if it's okay. And if you want me to explain again, I'm happy to explain again. But what I will do, though, is I will give you guys another question. So for those of you guys that actually understood what's happening, you can kind of carry on with these types of questions here. So we are going to go... want to wait. So if you guys have any questions, guys, just ask in the chat, and I'm kind of can answer through. But if D makes sense, then have a go with E. No, Friction, you cannot. That's the end. Guys, I'll give you guys another 30 seconds for this, and then I'll actually go through this question here with you guys. Peterson, I do level 2. It's on Mondays and Wednesdays, and I think we're probably pulling off another day in one of the weekends. So go, I really should be putting up those 2 playlists. I'll actually do that after this, so you guys can actually see that those 2 sessions that I've been doing comes at the top of my channel. But anyway, let's get going with this. Now 108 here. One thing that you guys can do is that if you don't know which kind of square root number, but like the square number you should be working with, what you could always do is just start kind of messing around with it. So I usually go divide by 2. Well, that's 2 and 54. I can't really use 2, so I'm not going to use 2 in this case. What about 3? And you can see that 3 and 36 is actually a square number, so therefore I'm going to use 3 and 36. So I'm going to split 108 into 36 times 3. X cubed, I'm going to split it up as x squared times x. Y6, I'm going to leave it as it is. And Z, I'm going to leave it as it is. I'm not really going to touch anything with Y or Z. So the next thing is looking at what are all the things I need to actually do square root of. So that's going to be 36 x squared y6. So I'm going to pull that out. So I have square root of 36 times square root of x squared times square root of y to the power of 6 multiplied by square root of 3xz. And once I do this, square root of 36 is 6, square root of x squared is x, square root of y6 is y cubed, and that's multiplied by 3xz. Friction, that should not have an x squared, it should be x by itself. Because square root of x squared is just x to the power of 1. Sweet guys, if we are good with that, we are going to start kind of shifting up a gear now. So we're going to do some addition and subtraction real quickly, just so that you guys get the hang of it, and then we're going to go to multiplying and division. I particularly want to spend a lot of time in division because that's the one where we kind of need to spend most of the time. Anyway, so we are going to F now. So we're going to go to multiplication. So with multiplication, addition and subtraction. Now I'm gonna be honest, guys. Like I don't really want to spend too much time on this. Maybe like 1 or 2 examples. But basically, if you have something like this, let's say you have 7 root 2 plus 3 root 2, then this is equal to 10 root 2. The reason is because this is the similar idea of 7x plus 3x, which equals to 10x, because that root 2 becomes your like term. Okay, so if you look at another example, if you want to do subtraction, let's say you do something like 8 root 3 minus 5 root 3, then this becomes 3 root 3, because this is, again, similar idea of 8x minus 5x is equal to 3x. Okay, so that's pretty much what addition and subtraction is. I'm only going to give you guys two problems for you guys to do here, and then we're going to try and kind of move on. I'm not really going to do the algebraic ones because pretty much you get the idea of what happens once you start. Well, we'll do one algebraic one. So where did we get up to? C, D, E. So we will do question F. Question F, I'd like you guys to do square root of 28 plus square root of 63. And then G is going to be square root of 56 minus square root of 14. Answers, again, has to be in surd form, which means you're going to have a square root symbol in the end. So as always, guys, we're going to give about, I'll give you guys about a minute for this. Yeah, friction. No, it's not hard. It's just, I just want you guys to kind of get the hang of, that's why I'm not giving you guys like, 20 or 30 problems to do. It's just like a couple of problems, just so you get the idea, and then we can just move on after that. Okay, I am going to give you guys one more question at the bottom there. Actually, no, I'll go to the side here. Okay, so FGH is what I want you guys to have a go at. What's the time? Half an hour. Rationalization of Serdes, Conjugate Surds, and then we're finished. Sweet. Guys, I'm going to give you guys another 30 seconds, and then I'll actually go through all three answers together. Revish, you do get to use the calculator for this exam, but these types of questions, having a calculator is not going to help you because they actually want you to use, the surds, and that means they just want to make sure that you actually are comfortable with doing some really basic number manipulation. That's all. Resham, square root of 14. All right, nice. Can you go any further than that? No. Cool, so I'll start doing F first. Looking at the number 28 and 63, I can tell straight away that it's a multiple of 7. So I'm going to rewrite this as 4 times 7, and 63 is 9 times 7. So this would be square root of 4, square root of 7, plus square root of 9, square root of 7. So I'm going to get 2 square root of 7 plus 3 square root of 7, which equals to 5 square root of 7. As for G, looking at the number 56, I guess, looking at 56, you can kind of get stuck in it because you'll be like, well, you know, the only thing that goes with 56 is 56 1, 28 times 2, 14 times 4, then what you got, 7 times 8. So the only combination where you've got a perfect square is 14 and 4, because that 4 is the number that you can actually take square root of. So that means that's what you got to go with. So I'm going to go with 4 times 14 minus square root of 14, and also there is a square root of 14 here, so you kind of see that, okay, that's what we're going to end up with. So we're going to get square root of 4 times square root of 14 minus square root of 14, so you end up with 2 square root of 14 minus square root of 14, so this just becomes 1 square root of 14. Hopefully you guys are okay with that. And then now moving on to h, we have to do what we did just previously. We've got to split up everything that we can. So the 18, I need to split up the 18 first to 9 and 2. And then I've got x times y squared minus y square root of 2x. I'm not going to do anything to that y 2x. I'm just going to leave it as it is. So in here, I can see that square root of 9 can be done and square root of y squared. So doing square root of 9 outside, square root of y squared, and whatever's left over is the 2x part. So the 2x ends up being left inside the square root symbol. So square root of 9 is 3, square root of y squared is y. So I get 3y square root of 2x minus y square root of 2x. So 3 take away 1 gives us 2y square root of 2x. So if you guys are okay with this, we can move to multiplication and, well, multiplication and division next. So that's what's coming up. So if you're okay, just give me if you're ready to move on, just say yes on the chat. Where did I lose you, Ravish? Okay, guys. Ravish, just ask the question, and I will try and help you in the background, or some of the other guys can actually help out as well. So we now go to multiplication and division. So multiplication and division, as always, there is a couple of Ravesh, just hold on to that question. I'm going to come back. We can come back to it. The second part. That's all right. I'll come back to that question, Ravesh. So, guys, multiplication and division. Basically, a couple of rules that pop up is this: if you have square root of p times square root of q, you can actually say that this is the same thing as saying square root of p times q. And likewise, if you do square root of p divided by square root of q, then this is saying square root of p over q. the most common mistake that I've seen people do is this. Just because they see this, they think that square root of p plus square root of q equals square root of p plus q. Now, that is absolutely incorrect, all right? This rule only works for multiplication and division. So I just thought I'd actually bring that up there for you guys. So it's only for multiplying and dividing. So if you look at a couple of quick examples that we're going to do. Where do we do? So if I have square root of 2 times square root of 3, this could be written as square root of 6. If I have something like this, 5 square root of 2 times 2 square root of 5, maybe not 5, let's go 3, then what you do is you've got 5 multiplied by 2, which equals to 10, and then square root of 2 times 3, I'll actually put that up there. So you end up with getting 10 square root of 6. Okay, and likewise for division, we will come back to division, but yeah, that's just the basic idea. So I'll give you guys a couple of questions. So we were up to I believe. The first question would be 3 square root of 10 multiplied by, let's do, cool. As always, guys, 30 seconds, 2 quick questions to get it out of the way. And just for kicks, I'm going to give you guys one more question there. So you guys got 3 questions there, IJK. So now we start using some of the basic algebra that we did in level 1 and 2, which is dealing with expanding quadratics and expanding brackets. Same rules apply here, guys. It's pretty neat when people start putting the answers up and you get like 2 or 3 answers that end up being the same. Then you know you're on the right track. All right, guys, let's start doing some of these questions here. So the first thing is this. You've got 3 times 2, which happens to be 6. So that's the 3 times 2. And then you've got square root of 10 times square root of 15 is going to be square root of 150. Now, as I said, we've got 150, which is an ugly looking number. Let's see. If I go 150 divided by 4, yeah, that's not going to work. Maybe I'll try 150 divided by 9. No, that's not going to work as well. Try 16. Nope. 25. Okay, there we go. 25 and 6. So I'm going to, because 25 is 5 squared, so I'm going to rewrite this as 6 square root of 25 times 6, which means I get 6 square root of 25 square root of 6. Ends up being 6 square root of 25 is 5. And I do square root of 6 by itself. So 6 times 5 is 30, and so my final answer is 30 square root of 6. Okay, as for the next one, we are looking at expanding the bracket. So square root of 3 times square root of 5 is square root of 15. And here's another little really quick trick, guys. Square root of 3 times square root of 3 is just going to be positive 3. Because if you think about it, you're going to get square root of 3 times 3, and then that ends up being square root of 9, which equals to 3. All right, and looking at k, we're going to have to do it like a quadratic. So square root of x times square root of x is x. Square root of x times negative square root of y is going to be negative xy. Then we've got these two inside brackets, which is going to be positive square root of xy. And then finally, square root of y times negative square root of y is going to be minus y. And looking at the inside terms, they cancel out each other. And so you're left over with x minus y. So Revish, you've got to keep simplifying it all the way to the end, man. So that's just something that you got to do. Now guys, with division, it's just pretty much the same idea. But we are going to go into something called rational denominators, and I'll talk to you guys a little bit more because we only got like 2 more bits to do, and then we're done with Surds. So, we ready to move on from these 3 questions? Okay, I'm going to assume that you guys are good with this. We are going to rationalization of Serdes. So that's going to be example 5. Yes, Friction, but before we get to the conjugate, we're just going to quickly run through writing it with a rational denominator. Okay, basically that means you got to have you can't have a square root symbol in the denominator. And this part is really important, guys, because this actually leads up to complex numbers quite a bit. So that's why I generally like to spend a little bit of time on this. So basically, the idea is this. So we're going to example 5a. If you have something like 1 over square root of 3, the whole process of rationalization is making sure that there's actually no square root symbol in the denominator. All right, it's okay in the numerator, but you do not want to have it in the denominator. That's the whole point behind this. So if you look at this, in this case, we've got square root of 3 in the denominator. That means we want to get rid of that square root symbol. And the only way we can get rid of that square root of 3 is actually by multiplying the denominator with another square root of 3. But that means we also have to multiply the numerator by square root of 3. And so when we do this, now the two numerators get multiplied by each other, which means you're going to get square root of 3 times 1, which is equal to square root of 3. And then in the denominator, square root of 3 times square root of 3 is going to be positive 3. All right, this is all that there is to rationalization of surds. Because if you look at the denominator now the denominator does not have a square root symbol at the bottom. So that means we have rationalized it. Okay, let me show you guys another example. So let's say we have something like this time. So at the moment, in the second part here, what we have got is we've actually got square root of 5. And that's the only thing we need to actually get rid of, just the square root of 5. So that means I'm going to multiply the denominator by square root of 5 and the numerator also by square root of 5. And when I do this, what ends up happening is in the numerator, I've got 3 times square root of 5. So that's going to be 3 root 5 over 2 root 5 times root 5 is going to be 5. So that means my final answer ends up being 3 root 5 over 10. And as always, if you look at the denominator does not have a square root symbol in it. So this process right here, guys, this process is what is called rationalization of surds. So that basically means that you are actually getting rid of the square root symbol in the end. Like I've seen it a couple of years ago, but not like this. I'll show you the later one. Like when we get to the conjugate basis, you'll actually start seeing them. They don't give you guys this simple types of questions, but the one after this, I have seen it appear in achieved level kind of questions. Cool. So ideally, guys, let's do a couple of real quick questions. I want you guys to rationalize the denominator. So let's see, give you guys some couple of easy ones to kind of get off. Starting with, we have got IJKL. That's it, just a couple of questions, and then we're going to go to conjugate surds, which is the last bit that I want to work with you guys today for. Yeah, you're on the money, Lucas. These are kind of like your building blocks to actually do bigger problems later on. Okay, so looking at that first one there, multiply by square root of 2 and square root of 2, and what you end up with is 16 square root of 2 divided by 2, and of course 16 over 2 can be written as 8, just 8, 16 over 2, so it's just 8 root 2. Fraction, you can simplify it further, I think. Yeah, that's better, science to go. So yeah, this is what I mean by like doing these types of questions with some really basic numbers. You need to start looking at, can I actually simplify this further than what I'm just leaving it out here, because sometimes that makes a huge difference when you're doing some of those bigger problems that you don't want to be working with big numbers, especially when you can simplify it further. So looking at question M here, I am going to multiply by square root of 10. Square root of 10. And what I'm going to end up with is 5 root 10 over 2 times 10. So that means I've got 5 root 10 over 20. Now 5 and 20, you know, they can be simplified because 20 can be divided by 5. So what ends up happening is you're going to end up with square root of 10 over 4, because 5 over 20 is 1 over 4. Jeez. What, you can simplify it. Friction, if you can't simplify it, then you know you can leave it as it is. Like, but in most cases, you always got to keep double checking that can you actually simplify anything further. So guys, if we're okay with this, I can go to the last part of today's session, which is probably the most important one, which is working with conjugate of these things. So conjugate surds, that's the word I was looking for. Cool. Can we actually move on from this one? If you guys are happy with it. Okay, considering that it's quiet, I'm gonna move on. So this kind of like sums it up for the last part of today's session, guys, which is conjugate surds. All right. Now, what do we mean by conjugate surds? So basically, it is the same kind of process that we've been doing so far, but the only thing is like this: if you have something like this, A plus square root of B, then its conjugate is going to be A minus square root of B. That's all. Oh, thanks, science ago. Okay, so, and similarly, if you have A minus square root of B, then the conjugate of that is going to be A plus square root of B. All right. Now, the reason we want to be working with the conjugate is because I'll show you guys a real simple question to start off with, and show you why we actually end up using conjugate surds. So let's say we go with example. I'm going to pick a random question, guys. Now, this might not actually look pretty, but let's just see what happens when we try and do this. Okay, so right now we want to simplify this. Now, remember, in the previous case, what we did was, what did we do? In the previous case, we did stuff like this, right? So I want to show you guys. If it was like this, 2 root 3, if we want to rationalize the denominator, what we'd do is we would multiply by square root of 3 and square root of 3. Because what that would mean is you end up with a denominator that doesn't have a square root symbol. So if you want to get rid of this square root symbol in the denominator, but you have also got another term and it's particularly being added or subtracted, then you've got to actually multiply the denominator by its conjugate surd. So what we're going to do is we've got to multiply the 1 plus root 3 with 1 minus root 3. And we're also going to do that in the numerator as well. All right. And I think if you guys remember, I gave you guys this question earlier with not just that. I think if you think about when we do quadratics, and I think it's called difference of two squares, you know, when we have something like x plus y times x minus y, we end up getting x squared minus y squared because the inside term, they cancel out each other. So that's literally what we're doing here to try and get rid of that square root symbol. All right, so we're going to multiply the conjugate of that denominator. So that means the numerator now is going to look like this: 2 times 1 minus root 3, and the denominator ends up being 1 plus root 3 times 1 minus root 3. Now I'm going to be honest, guys, like the more practice you do in this, like you actually skip out a lot of these steps later on because you just go, I know what I'm doing here. But I'm going to do the numerator first. So I've got 2 times 1, which is 2, and then 2 times negative root 3 is going to be 2 root 3. And the whole thing is now divided by, I've got 1 times 1, 1 times negative root 3, root 3 times 1, so that's going to be positive root 3, and then root 3 times negative root 3, which is going to be negative 3. So at this point, you guys can see that these two things cancel out, and we left over with 2 minus 2 root 3 divided by 1 minus 3 is negative 2. And we want to make sure that we don't actually leave anything in the denominator, because especially with this, we can actually get rid of that 2. So we're going to rewrite this as 2 over negative 2 minus 2 over negative 2 root 3. So 2 divided by negative 2 is negative 1. Negative 2 divided by negative 2 is positive 1. And we're going to end up with negative 1 plus root 3 as our final answer. So guys, that is basically what a conjugate, like using conjugate surd is. I'm just going to give you guys a couple of questions, and after that we will actually call it because I know it's already 9:57. So yeah, we'll just do like a couple of real simple questions, and I think I will leave that with you guys. And if you guys do have your workbooks and stuff like that, you can pretty much go through these questions on your own. But as promised, here is 2 questions. So what did we get up to last? M. So N, I would like you to do sorry, just give me a second. So I'm going to leave these 2 questions, guys. Of course, they do get a little bit more complicated, but you know, like we only got an hour, and I think I've pretty much covered this. This is like pretty much like a whole week's worth of work in 1 hour. So yeah. But no, I'm going to be hanging around anyway to try and kind of help you guys out through this. But these are all the questions we're going to do today, guys. For N and O, I'm going to give you guys about 5 minutes to try and do this. And then I'll actually go through the answer for N and O together after 5 minutes. Revish, can you tell me which step number, you've got a problem with? I'm just putting some numbers there so you can kind of tell me which one you're having a problem with. Step 4. Okay, step 4. So step 4 is like this. So if I have something like a plus b divided by 2, I could rewrite this as a over 2 plus b over 2. So I'm just splitting the fraction, that's all I'm doing. Sweet. -1, a +1 cancel out each other. -1. No, because remember that square root of 3 is like it's a term, it's a like term. What you're saying is like you're doing something like this. Let me just write it down. That's rubbish. That's like saying 1 minus 1x equals 2x. So you gotta treat the square root symbol like an x or like a letter, like a variable. Those same rules apply to this as well. Okay, I'm gonna get going with question N, guys. So question N, what you'll have is, so I've got 3 plus root 2 multiplied by 3 minus root 2 and 3 minus root 2. So the numerator, I'm going to get 4 times 3, which is 12, and then minus 4 root 2. The denominator, 3 times 3 is 9, minus 3 root 2 plus 3 root 2 minus 2, because square root of 2 times square root of 2 is 2. So in the numerator now, I've got 12 minus 4 root 2 divided by 9 minus 2 is 7. And in this case, I can't actually do anything. How did you guys get 5? Both of you guys got 5. Friction and sign to go. Square root of 2 times square root of 2 equals to 2. Four over 7. Thought so. Okay, as for O, I've got both of you guys made the same mistake. That's quite funny. Anyway, so in this one, I'm going to multiply by 1 plus square root of 2, and also the numerator by 1 plus square root of 2. So what I've got is I've got a big, ugly quadratic equation, but it's not really ugly. I mean, it's just what it is. So 1 times 1 is 1. 1 times square root of 2 is square root of 2. That's those two. Then I've got square root of 2 times 1, which is square root of 2. Square root of 2 times square root of 2 is going to be positive 2. And in the denominator, same thing. 1 plus square root of 2 minus square root of 2 minus 2. So looking at the numerator, I have 1 plus 2, which is 3. So I'm going to get 3 plus 2 square root of 2 divided by negative 1. So I'll just put some colors there so you guys can see where these numbers are popping up from. And now I've got to split them up. So I've got 3 divided by negative 1 plus 2 divided by negative 1 square root of 2. Now 3 divided by negative 1 is negative 3, and then minus 2 root 2. Friction, you've got something not correct there, because your denominator cannot have a square root symbol. Remember that. So guys, tell me if you're okay with those 2 questions, what I did. You guys okay with it? Can you solve more questions? Yes, but could you do more? I don't understand your question, Science Ago. I think this is how far this question ends up going. Like, you can't go any further than this. Yeah, it's very easy to make mistakes in this particular one, but I'm going to tell you guys this right now. This part here is the one where you want to be spending the most amount of time. Now, I don't mind spending like a whole session just doing questions like this the next time if you guys want, because trust me, this leads into complex numbers, and if you make mistakes in this one, you are definitely going to make mistakes when you start doing complex numbers. Sure, what's the time? I mean, 10 past 10. I'll tell you what, I'll put up one more question for you guys. Yep, sweet ass. Let's do one more question. What will shall we do? Which one did we just do? 1 plus root 2. Okay. Here we go, guys. Starting to really make your life miserable. Try that one. Okay, and if you really want to get complicated, minus. I think you guys are going to need about, no, 5 minutes to do this one. Just be patient. I'll be back in 5 minutes. Sorry, just coming in and out. Brendan Murphy, we're doing complex numbers. All right, guys, I'm going to start doing question P first. So we got square root of 2 plus square root of 5 over square root of 5 minus square root of 2. So we've got to multiply by square root of 5 plus square root of 2, and in the denominator, square root of 5 plus square root of 2. So doing the numerator first, I've got square root of 2 times square root of 5, which is square root of 10. Square root of 2 times square root of 2 is going to be 2. Square root of 5 and square root of 5 is going to be 5. And then square root of 5 times square root of 2 is going to be square root of 10. In the denominator, and here's the shortcut that I wanted to talk to you guys about, is that you could just go, because remember that how the middle term is not going to matter because it's going to become 0 anyway. So what you can then do is the first term, you just do these two things multiplied. So it's going to be square root of 5 times square root of 5, which is 5. And then you've got minus square root of 2 times positive square root of 2 is going to be minus 2. So that's it. So simplifying this, you got 2 plus 5 is 7. So 7 plus 2 root 10. And the whole thing is over 3. We can't really do anything for, that's the final part where we can actually go for P. So we're just going to leave it as it is. Okay, now getting on to Q. Looks ugly, but we will try and figure it out. So we are multiplying by the conjugate, which is square root of 5 plus 3 square root of 2. So square root of 5 plus 3 square root of 2. I'm trying to leave the space here and work, but let's see how this goes. So this is going to take some super concentration here, especially at 10:30 in the night, but let's give it a go anyway. So first thing, 2 root 2 and root 5 is going to be 2 root 10. Then I've got 2 times 3, which is 6, times 2, so that's going to be 12. Plus 3 root 5 times root 5 is 15. Plus 9 root 10. I hope I got that right. And as for the denominator, square root of 5 times square root of 5 is 5. Minus 9 times 2, which is going to be 18. So 12 plus 15 is 27. Plus 11 square root of 10 divided by 18 minus 5. And 5 minus 18 is going to be negative 13. Science to go. If you're going to do that, your answer, okay, I just got to be careful with that negative 11. I'm not sure how you wrote it, like, because if you put the 27 plus 11 over 11 square root of 10 in a bracket, then you should be good to go, science to go. But yeah, guys, that's pretty much what it is, how to do these types of questions. And if you guys are comfortable with this, then I'll tell you what, you know, you'll be pretty sweet with the complex conjugates, which is not too bad at all. Okay, so I am going to stop the stream because I know I went a little bit over today. I do apologize, but I guess this is for making up for Tuesday not being there. I am going to end the stream, guys, in about a couple of minutes. So if you have any questions, I will be on chat for a few minutes just to answer. But let me know if you guys are okay with those questions before I stop the stream. Negative 11. Well, you could do this as well. I mean, you could have actually done it like this, where it's negative 27 over 13. Well, it'll look like this. Hang on. Which means it ends up looking like this. So just another way of writing it. Not sure how you ended up with the minus 11 there, Friction. Good question, Ravish. Let me just have a quick check. Because we're doing excellence questions, if I'm correct, just with powers. Damn, Friday is looking very popular. Let me just double check with home, guys, see if there's no plans, but I will let you guys know tomorrow, Ravish, whether it's Friday or Saturday at the moment. Cool, guys. I'm going to end the stream at the moment, but as always, I'll hang around in the chat for another 5 minutes. So if you do have anything else, just feel free to ask. And thank you for joining. It's always nice doing calculus after a long time, especially not doing it in the junior college. Okay, catch you guys next time.